Welcome to solverfy.
Okay, another long problem. This time we're going to react this propyl grignard with a variety of electrophiles. First, if we react it with formaldehyde and water, of course this grignard is going to attack directly to open it up, but there's no leaving group, so it can only add once. So now we'll have our alcohol. Here are two hydrogens of the original formaldehyde. For B, we have this ketone followed by water. So of course, as the grignard attacks, we're just going to add to the carbonyl directly to get to this product. For C, we now have this acyl chloride. And of course, your grignard can actually attack twice, once to kick off the chloride, and then a second time to attack the ketone. So now we're going to have this alcohol with two of these propyl groups attached. For D, we actually have, seems to be an ester. And so again, we have a good leaving group. So we're going to add our grignard twice. We'll actually end with the same product. This is part C. For part E, we have a carboxylic acid. And in this case, this is an interesting one. You will not attack the carbonyl directly because you have a much better electrophile, which is this proton. So you're actually just going to generate this carboxylate and your propane gas. Of course, you have the magnesium salt with that. It's kind of the same idea with this alkyne. So here we have a very good electrophile. So our grignard is just going to deprotonate that directly, and we'll generate this anion, the magnesium salt, and our propane gas. For G, we're attacking with carbon dioxide. And so carbon dioxide is actually good electrophile. It's kind of a double carbonyl, right? So we're going to replace our grignard with a carboxylic acid. This carbon here is the same as that carbon. Okay, a little bit more space here. Yeah. H. Now we're taking our simple epoxide. So our propyl, this is the starting material, it's going to attack the less hindered side to open this the epoxide up. And here we'll have the propyl group attached. The workup, of course, it's going to go up here. Next, we just have D2O. Of course, this is like your proton source of water, so your grignard will attack the deuterium directly. We'll generate a single deuterium labeled propyl group, as well as your OD minus with your magnesium bromide counterion. Finally, we have this alkene with water. So this Grignard is actually going to prefer to attack the 1,2 position, but it is definitely possible for you to get a mixture of the 1,4 addition as well. I would think that the 1,2 is slightly more favored here because the 1,4 has this kind of bulked up side with the methyl substituent. So the major is going to be your tertiary alcohol here, but you may see some small amount of 1,4 addition byproduct.